Hi everyone, let's solve this problem. Find minimum in rotated sorted array. Suppose an array of length n sorted in ascending order is rotated between 1 and n times. So let's say for example this is the array. If they have rotated 7 times, we will again get to the same array. But let's say they are rotated it for 4 times. For the first iteration, 7 will be at the beginning, and then for second iteration 6 will come at the front, third iteration 5 will come at the beginning, and then for the fourth iteration 4 will come at the beginning. So this is the rotated 4 times rotated array, which is also sorted. Given the sorted rotated array nums of unique element, return the minimum elements of this array. You must write an algorithm that runs in big O of log n time. So basically there will always be a single answer, and this should run in big O of log n. We can use linear search here using big O of n time, and that is not going to help here because they want an answer in log n time. So we are somehow going to use the binary search. And just to show you a particular thing, let's say for example this is a sorted array. If let's say I am rotating for one time, you will always see that if this is a sorted array, all the elements on the right will be lesser than this. Let's say I bring 3 to the front, and if I consider this as a sorted left array, that means on the right again elements will be smaller. If I bring 2 to the front, if I somehow consider this as my subpart left, the elements on the right will always be lesser. Same thing, if this is the subpart, I'm sure that the element on the right will be lesser. So I just wanted to make sure that this point is clear because this is useful in one of our use cases. And now if we rotate it for 7 times, it will be the same array. In this case, we just have to return the answer which is present at the leftmost pointer. That's it. We don't really have to do anything else, right? So that is what we are going to understand now. So first is sorted, just return nums of left pointer. And for any binary search, we will have left right pointers, and we will somehow calculate the mid. So for any binary search, we will, if we found the answer, we are going to return from there, or we are going to have a left search space or right search space. So if this is the mid, we will always see if this is the answer, or if the answer lies on the left or answer lies on the right side of it, right? That is how we are generally going to navigate the binary search. Now let's for some time consider if my mid is at 4 instead of the 3 index. This is the answer, because how are we going to know this is the answer? If you see every element, 5 is greater than 4, 6 is greater than 5, 7 is greater than 6, but 0 is less than its previous element. So that is when we know that this is the pivot element, and we return the answer. And if you see 1 is greater than the previous element, 2 is greater than the previous element. So there will be only one element which is pivot, or our answer, which is nums of mid, and this will happen only when our nums of mid is less than nums of mid minus 1. Cool, we are done with this. Now we will actually solve this. So let's say for example, if the mid is at third index, now this particular left subarray is already sorted. The property which we have recently seen, no matter how many times I rotate, if there is a left subpart, the elements on the right will always be smaller than the left sorted array, right? The clear distinction is that if the left subpart is sorted, then the elements on the right will always be lesser than the elements in the left subtree. So if that is the case, if left sorted, then we are definitely going to search in the right subspace. That means we should just do L equal to mid plus 1. If that is not the case, that means for some reason, if my mid is at this point, this is not a sorted array, sorted left part. So that means the answer lies in the left search space itself. So I'm just going to bring my right pointer to mid minus 1. Right? Okay, now let's solve this. Mid. Now this is not the answer for sure, and this entire list is not sorted as well. 4 is not less than or equal to 2, so this condition does not match, this condition does not match. And is this a sorted left subtree? Yes, that means the answer lies on the right side of it. So my L pointer will be moving to the mid plus 1 position. And now if you see, this is a sorted array, left and right. If you see, now we have already discarded this part, that means this is the only array left, and this is a sorted one, so we don't really have to do anything. We just have to return the left number, because this will always be the lesser than that. So this is the entire solution. Now let's try to write the code for this. So initially left will be 0, right will be equal to nums dot length minus 1, while left is less than or equal to right, let mid equal to, okay, even before checking the mid, we should check if the list is sorted or not. If less than is less than or equal to nums of right, that means this is a sorted list, and we just have to return the first element, nothing but left. So this is sorted list. Now we have to calculate the mid, left plus right by 2, and then we also have to calculate the floor of it. Now if we have to check if mid is answer. So how are we going to check? If nums of mid is less than nums of its previous element, that means this is the answer. You can just return it from here. Else if left is sorted. So if left is sorted, how are we going to check? Left is less than or equal to nums of mid. In this case, what are we going to do? We are going to just ensure that left equal to mid plus 1, because we know that the answer will lie in the right subpart. So if none of the above cases matches, we are sure that we have to search in the left subpart. So we are just going to do mid minus 1. So towards the end, we will always have the answer, but towards the end we just return the minus 1. So now let's see by running the code. Let's submit it. Yes, it's submitted. And now let's also understand the time complexity of the solution. Time complexity is log n, and the space complexity of the solution will be big of n, because we are not using any extra space in this case. I hope this solution is clear. And one more thing is that if this particular part is not there, this entire part will not work. I'll show you the example as well. Let's say, for example, so when we have this left and right pointers here, we have this mid here. Let's consider this case is not present, like we are not handling this case. So in this case, left and right, if you see, this left subpart is sorted, right? If left subpart is sorted, we are always going to move to the right part. So this case will actually break here. So we always have to check if it's a sorted list. If it's a sorted list, we just have to ensure that we find the answer of leftmost element and return it. I hope the solution is clear. Thank you.